Having a good and meaningful coverage is still a big challenge for all network operators, especially in a dense urban environment where the presence of a large number of buildings and infrastructures gives rise to harsh propagation condition for electromagnetic waves, leading to lack of seamless connectivity. The major reason behind this issue is a lack of control over the propagation environment. So in this case, the propagation environment remains unaware of various communication process going through it. The engineered metasurface is a key to make this such passive environment smart. So this engineered metasurface, also known as large intelligence surface or reflecting intelligence surface or even hypersurface, can enhance the meaningful coverage by sensing the environment, recycling the existing electromagnetic wave and redirecting them toward the direction of interest.
By these structures, you can have a control on the reflected waves, and this is the beauty of these metasurfaces. We can control something that we literally cannot see.
You come across certain places which are called as coverage blind spots. You don't have coverage over those places. And to put up a new base station is quite expensive just to cover a small area. But with these kind of intelligent surfaces, you can cover those blind spots, ensuring that the user always has a seamless connectivity, even if it is moving.
As far as I know, this is the first demonstration in the whole UK.
This is our first scenario to find out the performance of the static metasurface. This is our receiver.
So we are streaming a video here over the 3.5 gigahertz band using software-defined radio from the base station to the UE. The base station is kept here and the UE is kept inside in an area where there's a coverage blind spot. But once we place our surface at the right position, the UE will receive a strong enough signal to decode the video stream and the video will play smoothly. So now I will start transmitting the video stream from here towards the metasurface.
And this process is done by this reflecting metasurface. There is no line of sight from the transmitter and this receiver. If we move the surface, we lose the video. And now my colleague is moving the surface. As you can see, the signal is actually lost.
At 6GIC, we have developed a dynamic version of this metasurface. This metasurface is quite different from the one that you just saw. The previous one that you saw was a static version, which doesn't require any power at all, and it works completely on its own. This one requires a controller. This can actually make the beam change its angle so that the coverage always follows the user and the user has a seamless connectivity.
So just let's try. If I press the reconfigurable mode, you can see now we have video there at the user terminal. My colleague is going to move the user toward another point. Again, you see the video stream is not getting decoded successfully. So now let's again use the reconfigurable mode and let's ask the metasurface to reconfigure itself. Now you can see we have received video because the metasurface reconfigure itself toward the new position of the user equipment. In the last scenario, we are going to demonstrate the capability of our dynamic metasurface to change the angle of the reflected beam continuously to follow the user as it moves, ensuring the seamless connectivity to the user. So let's try it with the tracking mode and let the metasurface to start follow the user.
In reality, it automatically do everything. Means detect the position of the user, change the beam, calculate based on the algorithm, and do everything automatically. That is very, very big achievement for the University of Surrey. We don't have anything similar in the world in this size, and these solutions means totally together. I think we are the first one.